Let us study about today's session. Today we are going to study the types of feedback amplifier. Before enter into the types of feedback amplifier, let us recap what we did in the previous classes. The previous class we studied about the feedback amplifier, the very basics of the feedback amplifier. Then we studied for a feedback amplifier for positive and negative, or at the same time we studied the principles of feedback amplifier. So we done some expressions also. So like finding the gain, like feedback amplifier or gain of the feedback amplifier that we studied already. I hope you remember that will be represented as AF. So in that we seen something called as the positive and the negative feedback. So normally in the feedback circuit we'll have only the resistors, the capacitors, that kind the elements only will be available. So now here already we said the amplifier feedback gain, or we can say feedback gain factor will be AF. AF is equal to A divided by 1 plus beta A. So this A represents the amplifier gain, the beta represents the feedback gain actually. So this is what we said. This plus indicates here actually we said if you are doing a negative feedback amplifier, then we'll get like this. If it is a positive feedback amplifier, we'll get the derivation as A by 1 minus beta A. So already we've seen with the diagrams and all. Now let us go for in elaborately what is under the different types. So here we can say what is the feedback. Already which I said, normally the process of injecting a fraction of output energy of some device back to the input. That only is nothing but the feedback normally. Normally the one of the very important advantage in the feedback is it's found the usefulness to reduce the noise, especially because as I said in the amplifiers, normally by default it will generate the noise. So the noise will be amplified in the output because we doesn't or we cannot say like whether the input signal only is amplified. So we may think the input signal is amplified, but sometimes what will happen along with the noise also it will be amplified in the output. So it will be very useful to reducing the noise and making the amplifier operation stable. So depending upon the feedback signal, it or it opposes the input signal. There are two types of feedbacks we used. As I said, positive feedback, negative feedback. The negative feedback will be used to design the amplifier circuits. Then the positive feedbacks will be used to oscillators. So if you are going to design any oscillator circuits, then so we have to use the positive feedback circuits. So that is what here the positive feedback. First, positive feedback. So here the positive feedback, it will which the feedback energy, that is the feedback, either sometimes the voltage or the current is in phase with the input signal. That's why it's called positive feedback. In the sense it will be in phase. See, keep it in remember, in phase in the sense non-inverting. Positive feedback will give you the output as non-inverting. That is what in phase. But both the input signal and the feedback signal introduce a phase shift of 180 degree, thus making a 360 degree of resultant phase. That is what normally what will happen when you are giving the input signal, the feedback signal will introduce a feedback signal normally will give the phase shift of 180 degree normally. So that making the feedback will be 180. The input signal will be introduced both together 180 plus will have the 360 resultant phase shift around the loop. So this finally in phase with the input signal. That is what we can say. With the help of the positive feedback, we'll get a non-inverted output. But though the positive feedback will increases the gain of the amplifier, but we may think so as we said the positive feedback circuit will be used for to design the oscillators, not for amplifiers. But even the positive feedback will increase the gain of the amplifier, but there will be some disadvantage also is there. The disadvantages are it will increase the distortion. The second is it's a instability. So due to this, actually these both are the very important disadvantage of positive feedback amplifier. Sometimes because of this advantage, the positive feedback is not recommended for amplifiers. That is why I said the positive feedback will not be used to design the amplifier circuits. But if the positive feedback is sufficiently large, then it leads to amp oscillations. So by which the oscillator circuits are formed. As we know, what is meant by oscillator? In your PU and all you studied, I hope you remember two different types of oscillators you might have studied. The one is Hartley oscillator, the another one is Colpitt's oscillator. But in the name of the oscillator, what is the meaning of the oscillator? The circuit which will generate the vibrations. That is the oscillator. Without giving any input, the circuit will generate the waveforms. That is the oscillator circuits are formed. So now here, this is the simple positive feedback circuit diagram here we shown. See here the input signal is represented Vs. Then here we had the summer. This circuit is nothing but a summer circuit. That is from here we are getting the feedback signal. This is your amplifier circuit. This will be your feedback network. The feedback network will be the form of what? Will be in the form of R and C actually. See, the first input signal will be, now you have to think, some circuits are there in feedback network. Vs is the input signal. Here the Vi is nothing but the combination of input signal and the feedback signal actually. This is a positive feedback. See, the plus plus is there. So I can say Vi is equal to, it is a summation of what? Vs plus Vf. That only is nothing but Vi actually. So the amplifier normal I can say, you forget about this. The amplifier, that is, it will produce the output as V naught. So I can say P naught is equal to, generally it is A into Vi. Actually A into Vi. That is something but V naught. But we know what is Vi. The Vi is something but Vs plus Vf. Now this A into Vi signal only will be fed back into the feedback network as input here. So here what I will have? Here I will have A into Vi. This one, right? Down here the output signal is called as, here the feedback signal is Vf. So from this I can write, we already discussed in the previous class, that is Vf is equal to, what is the Vf? This is the output of the feedback network. So Vf is equal to A into, or I can say beta into, because feedback network, beta into A into Vi. Then just to substitute for Vi, we know that is beta into A into Vi is nothing but what? Vi is nothing but Vs plus Vf. Then you simplify, finally we'll get one expression. So this is what we have to do the derivation, how we'll get. So now let us go for the negative feedback. So now we see the positive feedback, negative feedback. Only difference would be what? Here, see this negative is there. But here you can see positive is there. This is what only difference. Actual thing is, yeah, this is the summing point. This is the summing point. This is a V in. That V in is nothing but you can assume as like Vs. As I said earlier here, same you take Vs. This is Vi. So now as per this, the Vi is equal to what? Vs minus Vf actually. Because this is Vf. This is Vf actually. See, Vs minus Vf. But there Vs plus Vf will be there. Then other things are fine. So here this is, will get us open loop. That is nothing but what? It is a open loop gain. This G, or sometimes we can call it as A. The A is nothing but open loop gain. The attenuated beta, this is the, I can call it as feedback network beta. That is feedback gain. So now same here. See here what will happen in the negative feedback. The amplifier introduces a phase shift of 180 degree into the circuit, while the feedback network is so designed that it produces no phase shift or zero phase shift. Which one? This feedback circuit will not provide any degree, that is 0 degree. But here this feedback circuit, here positive, it will produce 180 degree phase shift. So now because of this, what will happen? We'll get the output as out of phase. That is the resultant feedback voltage. This 180 degree out of phase here I'll get. then with the input signal as Vn, then the output will be what? If I give the input as like this, I will get the output as in this way. It will be shifted 180-degree phase shift will be there in the negative feedback amplifier. Now, let us see what are the classification, the different classification of feedback systems. So now, so far we have seen that when the output signal is fed back, like normally in the previous diagram we've seen, the output signal was only, it's fed back into feedback circuit, that is fed back to the input terminal, and for feedback system, it can be either positive feedback or negative feedback. Now here, what are the different classifications are there? Here, there are four basic classification of single loop feedback systems. Four. So what are those four in the sense? One is nothing but voltage series feedback. Second is voltage shunt feedback. Third is current series feedback. Fourth one is current shunt feedback. This is voltage series feedback, can otherwise called as voltage in, voltage out, or voltage controlled voltage source. Sometimes we may call series shunt configuration. See, from this what I can say, the input is voltage, the output also is voltage. So this is the one configuration. Second, voltage shunt. You should know the shunt. Shunt is nothing but parallel. That is the meaning of shunt. Voltage shunt feedback means the current will be in, that is input is current, the output is voltage, or it's a current controlled voltage source. Sometimes you may call shunt configuration. Next, third, the current series feedback, that is voltage in, current out, or I can say voltage controlled current source, that is VCC. Yes. Next, fourth is current shunt feedback. So like this, four different configurations are there, but for us, all these four configurations are not required. Here we are studying only one configuration, that is nothing but voltage controlled voltage source. This only we are going to study. We are not going to study any other configuration. Only this only we are going to study. So, but just here I shown how these the diagrams and all will be there. The very basic, the voltage controlled voltage source, the configuration diagram will look like this. See, this is what? This is for your A actually. See, this one. So what is that we said? The input is voltage, correct? See, Vin. The input is voltage, output also is voltage, that is V naught. So now this portion you can see here, which portion? Here which is shown. This is nothing but the amplifier portion, that is A. You can, you have to think with the previous diagram, then this one is nothing but the feedback portion actually, that is beta actually. Correct. So now the input is connected to like source of Vs. Actually, see this, how the diagram, the same diagram, just we modified and drawn. The output we connected here one resistance. The resistance is something about what? It is here load resistance is connected in the output. See this, like positive, negative. So it is connected to beta. Now we return. This is something about your Vi. You can see from the previous one I written Vi. Then this will be Vs. Then this is your V naught out. See the output from this, it is connected to one portion, then from here to one portion, then this output will be given to here. The next one more is given to the portion of your source, that is Vs. So from this, as you know, what is A? A is nothing but what? It is nothing but V naught by Va. That is the ratio of output voltage to the input voltage. That only is nothing but A. So next is same. What is beta actually? Beta is something same. Even this is also a gain. Even this also is nothing but a gain. But this is the amplifier gain. This is the feedback gain actually. So the feedback gain means beta is equal to output by input. What is the output here? The output is nothing but VF normally, right? The input is nothing but V naught. They here. So I can say the B naught beta is equal to VF by V naught. So here A is equal to V naught. So in this expression, you should know, if we know this expression, so very easily we can solve. So this is for second configuration. This is for your reference. You can see how this diagrams and all we drawn. This is for your reference only. Just you can go through all these four configuration, but only one is only sufficient for us. So the for all four, the summary is given here, like voltage series, voltage shunt, current series, current shunt. What will be the gain without feedback? what is the gain with the feedback, what is the expression, then what is the feedback gain also. Here it is given. Because of in your voltage series, the output is Vf, input is V naught. Sometimes see here, I by V is there. See here, V by I is there. See here, If by I naught is there. Because of the current. So now what is, as I said here, we are going to deal with only one configuration, that is voltage series feedback amplifier or voltage controlled voltage source. That is VCVS. That is the first configuration. That only we are going to read this. So sometimes we can call it as series shunt feedback, because in your examination they may ask explain series shunt feedback amplifier, or sometimes they may ask voltage control voltage source, or sometimes they may ask voltage series feedback amplifier. So the series shunt feedback, also known as series voltage feedback, that will be operated as a voltage control feedback system. So now here the error voltage feedback, error in the sense the output feedback from the feedback network is in series. Both are in series connection. You can see this connection is series connection actually with the input. The voltage which is fed back from the output being proportional to the output voltage, that's the V naught, as it is parallel or shunt connected. See, this is shunt. This is parallel we are taking. Then this is connected over there. Now, this is what we can say open loop gain. So we don't get any confusion. This is A, this is B. Here they given us H. So don't get any factor confirmation. This is nothing but a B, beta actually. This is A. Now, as you know, how to perform the expression for this, how we can do the expression. Say based on this, some for the series shunt connection, the configuration is defined as output voltage, that is V out, to the input voltage V in. So V out, this is V naught, then this is VA. Some most inverting and non-inverting operational amplifier circuit. Do you remember your operations amplifier, that is op amp? Circuits operate with series shunt feedback, producing what is known as voltage amplifier. Now, as the voltage amplifier will have ideal input resistance, that is Rin. This Rin will be, that is input resistance, Rin, normally it will be very, very high. And the ideal output resistance, the R out will be very, very small. That is R naught will be very, very small, but the R in will be very, very high. Then the series shunt feedback configuration will work as true voltage amplifier, as the input signal is a voltage and the output signal also is a voltage only here. So here, if there is no feedback, assume if there is no feedback yet, what will happen? The output, whatever the input you are giving, just it will amplify, it will produce the output. So then the voltage, what will be the voltage gain? Now from this figure, you have to assume that is this, there is no feedback amplifier, means because zero, there is no connection over there. Then what will be the gain of the amplifier stage here? So that is very simple. We'll get A is equal to V naught by Vs. As we know earlier, is equal to V naught by Vi. This we know because initially only we studied this. Now, if a feedback signal Vf is connected in series, this is without feedback. This is without feedback. If you're connecting the feedback, then automatically the expression will get changed. Finally, we'll get as AF is equal to V naught by Vs is equal to A by 1 plus beta A. This is nothing but the overall voltage gain with feedback. So you have to keep it in your mind this when you're asking the formula. This is which feedback? It is a negative feedback, but the overall voltage gain with the feedback is AF, the factor AF, that is feedback gain. AF means shows the gain with the feedback is amplifier, which will gain reduced factor of 1 plus beta A. Now you see here in this AF, which one? Yeah, feedback with the feedback is amplifier gain. Which is the feedback amplifier gain? That is AF. That will be reduced by the factor of 1 plus beta A. Why? Because 1 plus beta A, if it is very, very greater than value, then we'll get A as the value. At bar, sometimes your beta A will be very, very greater than 1. What will happen? If it is greater than 1, that expression will be reduced as A by beta A, then AA will get cancelled, then I'll get 1 by beta. Automatically I can say the shows the gain, it will get reduced actually based on this value. As the beta value increases, then the AF value will get reduces as the beta increases. Now, what is the input impedance of the feedback? We need to find out the input impedance. So just very simple in this diagram, the input impedance will be II is equal to VI by ZI. The input impedance will be denoted as ZI. It is nothing but the impedance is nothing but simple. We can say it's equivalent to resistance. Something we can say IA is equal to VI by ZI. What is VI actually? We know. Just you have to assume like this from the previous diagram only. The VI is nothing but Vs minus Vf. That is nothing but Vs minus Vf. So where the Vs is nothing but source voltage, where Vf is nothing but a feedback voltage. Now substitute what is Vf? Vf is beta into V naught, then Vs minus beta A into Vi. So then simplify this expression. The finally will get us the input impedance as like this. Zi into 1 plus beta A. So from this, we can say the input impedance with the series feedback is seen to the value of input impedance without feedback multiplied by a factor of 1 plus beta A. See here, it is multiplied with the factor 1 plus beta A and applies to both voltage series and the current series also. Now this is for input impedance with the feedback. Same the way, this is the input side. Example here, input side, you have to connect the one resistance, output should be open. Next, what you have to do, you have to open this. In the output side, you have to connect one resistance. Then you have to calculate the output impedance. The output impedance for the connection, the figure, whether the voltage or the current feedback is used. So from this, how we'll get in the sense, the output impedance is determined by applying the voltage V, resulting in a current with the Vs shorted, Vs is equal to 0. That is nothing but what? Your source voltage is equal to 0 because you have to make open circuit. The voltage V is equal to I Z naught plus AVI. So from this, we can now just you have to write the output impedance with the feedback. This is the expression ZOF is equal to V by I is equal to Z naught by 1 plus beta A. So this is the factor. The voltage series feedback and output impedance will be reduced from the feedback factor 1 plus beta A. Why? Because when beta A is very, very greater than 1, then the one will be emitted is that not by beta A. Then this value is get increases, so that will be get affected. So now the overall gain for the negative feedback will be like this. See, already as I said, AF is equal to A by 1 plus beta A, where beta A is very, very greater than 1, A by beta A, then 1 by beta. This is what already as I said. As long as beta A is very, very greater than 1, the overall gain will be 1 by beta. So for a practical amplifier, the open loop gains will be dropped at the high frequencies. Now here, this is nothing but frequency wise, we can say, see here. Okay, so this we'll study the next step, the effects of the negative feedback. So what are the different effects will be there in the negative feedback?